Okay, here we have some of the tools of the trade for bell casting. We have a sand mold, some residual castings, and a crucible. We use Bell Bronze Industry Standard 913 to cast all of our bronze bells. They're heated up to about 1500 degrees and poured into the mold. Here's a match plate that we use to actually make the sand casting mold. You make a cope and a drag from this, as you can see there. This is our general machine shop with two brads here. This is where we do a lot of our punching for springs, general tooling, any specific tooling that we need for our lathe or our part along those lines we would do in here. This is just more of our machine shop where we do some drilling, some tapping operations for our bell making process. Now we're leaving the general machine shop and entering into the main machine shop where basically all the magic happens. A roll casting that we'll get. This is going to be an F6. This is the way we get them in-house. And we'll go about removing probably about 2/3 of the metal on this. Casting will come in. We use two foundries more or less. Casting will come in. We'll do a quick inspection, take a look at it to see if there's any sort of visual or aesthetic imperfections. We'll drill a center hole here that allows us to put it on one of our lathes. This is our lathe room. We have 8 lathes in here. Generally speaking, 5 OD, 3 ID. One in the back is a CNC. And the rest are all mimic tracer lathes that have all been retrofitted for specifically for production of bells. The way bell tuning works, it's kind of like a series of steps. The bell comes in a small form that's at the top of the stairwell, or at the top of the steps. And each process that we put it through that removes metal basically essentially detunes the bell. So it'll walk down those steps. We have certain trigger points within those steps that we want to meet in the production process. So we'll get a raw casting here after we check it out and check it out alright. So here we come into our machine shop. We have a drill press over here that we actually use for drilling out a center hole for the castings. Over here on the right we have an OD machine. As I'm walking back here, another OD machine there. This is an OD machine. It'll do some of the mid-range to higher octave bells. Again, it's just a mimic tracer lathe. Over here you can see actually the pattern and the stylus. And the stylus will just follow that pattern, and that'll control the tooling to take off a certain amount of metal that we want and give us the profile that we want for that specific bell. Next we're going to go up and see a tracing of a bell that has just come off a lathe. This is how we ensure that the profile is adhering to our master profile. Diet here is chucking up a bell, and he's going to take a tracing of the outside profile of the bell and match it to one of our master templates. The purpose of the profile is to create a strong fundamental and a complementary overtone with acceptable sustain for both. For Malmark, we tune the fundamental, and the overtone for us is the 12th. The important thing about this is to make sure that the shoulders of the bell are not too skinny or wide enough. The length of the bell is appropriate, also the diameter. Tuning, generally speaking, is a product of the thickness of the wall of the bell, the diameter of the mouth. So it's very important that those adhere to the master profiles that Jake designed when originally creating the profile for the bell. As you can see here, he's taking the outside and just tracing it to a piece of paper, and then he'll do the same for the inside. Diet's been doing this for almost 20 years now, so he's well schooled in this art. And there you go. As you can see, Diet now has taken out a master transparency to match up the tracing of the bell to the template, or the transparency to make sure it matches. And if it does, it's considered that the machine was set up successfully and will then run a run of the bells. That looks good. Here we have Diet tuning on one of our larger machines. This will tune F3 to B3. This is an ID machine set up similar to the OD machines, where you have it's a mimic tracer lathe, where you have a template and a stylus, and that follows it and controls the tooling on the machine. Second to last pass is here, where we'll actually we'll check the tuning for the first time, make sure it's tracking accordingly. If it's not, we'll adjust the machine as needed. These machines, we basically are concerned with two axes, the X and the Z, the X being the in and out, and the Z being the length. We use Peterson strobe tuners to check all of our tuning. This is another OD machine in action, as we shown earlier. We'll run about 5 or 6 passes, and depending on the size of the bell, it could take anywhere from 5 minutes to 15 minutes to 20 minutes to do an outside diameter of a bell. This is a CNC that we'll use in another OD or ID machine. As you can see, these blue barrels, these are all the shavings for the turnings from the bells. We'll send them out and have them reprocessed, so nothing really goes to waste. So now, as we left the machine shop, we come into the polishing room. This is probably the most dirty and physically demanding of any of the jobs in Malmark, but also probably the most important. The bells that leave the machine shop will come in here roughly a semitone high, depending on the size of the bell, but that's a general rule of thumb. And this will allow us to remove the metal necessary to bring up that really jeweler's shine and polish that's a trademark of the Malmark bell. We'll remove, again, about anywhere from 50 to 100 cents off the tuning of the bell in these processes. It's a 3-step process, starting from the right, working its way around to the left. You have sanding and polishing here, as Ty's doing. And then the next process would be external polishing, and then a buffing. This is where we use the machine we use to cut the tang off. And then, as you can see, we're always checking the tuning. We have our Peterson strobe tuner in here as well. We check the tuning roughly about 3 to 4 times in this room. So after this room, it's probably been checked about 6 times overall. Keith in the back there, as you can see, he's doing getting ready to do an aluminum bell. We're the only company in the world that manufactures aluminum basso profundo bells. Tung, he is doing some external buffing using just a coloring agent that really brings up the high jeweler's luster and shine of the bell. The hardware are the guts of each bell. Each bell is going to get a clapper assembly, handguard, and a handle. Everything's made here. There's not a lot of vendors that are going to supply clapper assemblies for a C6 handbell, you know what I mean? So everything's done basically in-house. We get the raw materials and we do the process. Everything's been engineered specifically for bells. Jake Malta, who's the founder of the company, he basically designed all of this from the process to the final product. So after the bells are assembled, it's taken, and hopefully somebody's in the voice again. Back here on the right is John Zerby, long tenured employee. He's going through a refurbishing. In addition to making new product, we also bring back a lot of bells. Customers want them refurbished. Here is a little bit of the bell graveyard. Malmark rejects 35 to 40% of its bells because they don't meet our strict tonal quality standards.
When the bell is ready for voicing, that is middle. This one is ready voicing, but I want to show you. The toner. I check in the casting around. I check it for the best sound. Over here is good. You hear the difference is wow wow. When we find that the good spot, what we do and scratch over here in the little scratch. The second tone, I check in the second tone too.
Yeah, well, it's not in the, certainly not in the forward. You can, when you speak, remember, I can tell that you already thought you already ordered it, and I'll just tell
When it's ready in the two-tone, I put in the little scratch here. This is ready for go out. Just blend it. And this is the same. You hear? Sometimes, some bell is like this. You hear about shaking around. Around is the over there is much better. You hear? When we found that the best, this one is reject. When we found that the best part, this is ready to out.
So this is our sub-assembly department where we actually assemble all of our clappers. So from the head to the shaft to the yoke, they all get put together here and then passed over into final assembly for assembly within a bell. This is Twan. She's actually putting in some bearing screws into a yoke. So here we are in our hand-guarded handle department. This is Lorraine. She's kind of an army of one, takes care of it all. Our handles are a two-part handle. There's a sleeve and an insert with a note designation that goes on the inside. What we do is we heat that up in the oven, and as they come out, they'll be wrapped around a mold, cooled in an ice water bath, and put in those racks overnight for memory. Ken here, he's putting the dimple into the clapper head for the indexing spring.